So right now, I would like to welcome Dr. Ed Mclarty from NASA to introduce our next keynote speaker. And I will bring up her slides right now.
I get to hang out with a lot of doctors, but I'm not a doctor myself, so that's okay. Hey, my name's Ed Mclarty. It's my pleasure to introduce Ms. Jill Marlowe to you. She has served the nation at NASA for the last 32 years. She started her career in aviation, human spaceflight, and space-based remote sensing. She has increasingly difficult technical degrees from Virginia Tech, RPI, and George Washington University. In the time that I've known Jill, she's been an SES lead she's rocked the leadership for 4 different SES roles, most recently as NASA-wide leader of digital transformation. I'd like to tell you about a few of the roles that I've observed her conduct in that process. Sometimes she is the oracle scanning the horizon and helping us envision the future. If you've seen the internet meme, sometimes she's the crazy dancer on the concert hill getting everybody else to join in. Other times she is the architect or composer to create a roadmap or a common sheet of music. Sometimes she's an artist turning complex concepts into simple diagrams that are powerful that we can all get behind. Sometimes she's the conductor guiding harmony among many players. Sometimes she's an advocate, finding investors, benefactors, and fellow true believers. Sometimes she's a coach, preacher, counselor, getting our little band through difficult times. Other times she's the lead singer, passionately getting the word out, like today. Since this is DataWorks, you might expect the song to be, like we heard with the general, it's all about the data, about the data, about the data, and the people. We believe in that song, but Jill's got another song, and that's how we are living in a transformational world. Jill's a transformational girl. With that, Jill Marlowe.
Oh my goodness, Ed's introductions are always just a joy. I will tell you, I would have been disappointed, Ed, if you didn't work music into that somewhere. If you know Ed, you know he is a passionate musician on the side, and we often blend the streams. So first of all, let me just say, I don't know how to give an in-person keynote. I realized it's been more than 2 years since I've actually been in person, and I'm so used to like talking to a bunch of dots and monitoring chat to read the room. I'm going to need you all to kind of coach me on body language again as we go through the discussion this morning. So I'm very excited to be here in person and relearn some of that muscle memory, and I'm really hoping that you'll make squunchy faces or kind of faces in the audience so that you can help me read the room as we go along. So this particular conference, you kind of had me at hello. First of all, I read the technical program, and digital transformation themes are all over what you guys are doing. And we'll talk about how we characterize digital transformation at NASA. But the other part is this community is kind of my roots. I actually started my career as a structural analyst, turned structural dynamics, and kind of went on to lead some research and engineering organizations at NASA. So the applicability of some of the digital advances that are coming along now to this particular technical forum, you had me at hello. So what I'm gonna do this morning is I'm gonna take you up at 100,000 feet and talk about why is NASA even engaging in digital transformation, and then we'll swoop way down to what does that look like, how does that show up for this community, and then hopefully we'll bring you back up again and say, hey, how can this community really help propel the whole reason why NASA got into digital transformation in the first place. So with that, let's talk some context. So NASA has an amazing mission. And I actually try to pull up this chart on a fairly regular basis because it reminds me of why I came to NASA in the first place. Our mission is to reach for new heights and reveal the unknown to benefit all of humankind. Who gets to say they do that for a living, right? Like that is incredible. We do, those things through incredible missions, but mostly it's about pushing the forefront of technology so that we can do that discovery and push to kind of have those next sets of breakthroughs and share that, usually globally. We're an icon, right, for the world. What that's looked like over our history is, starting, if you kind of go back to some of the early days before we were even NASA, when we were the NACA, we were pushing the speed boundaries. Here, let me pull up a laser pointer real quick. We were pushing the speed boundaries. There's Chuck Yeager, right? Supersonic flight. This is an image from Hubble, discovering the origins of the universe. That's kind of then. That's in the rearview mirror for NASA. What we're doing now, massively complex climate models, trying to predict how our human behavior is actually influencing climate. Just earlier, this year, or last year, I guess technically it was now, flying a helicopter on another planet, for goodness sake, that basically had no atmosphere, right? All to kind of transform how we can acquire information on what's happening and habitability and how humans could take advantage of life on other planets. And then what's next for us? Our signature Artemis program. This is all about sending the next man and the first woman to the moon as a sustainable campaign, right? This is about a proving ground for living life off planet Earth, close by, near home, all so that we can kind of go on to human exploration of Mars. So this is what we're doing. The problem is, the challenge is, that bold mission, we now have to do it in a rapidly changing world. And you can see on the slide here some of the attributes that are confronting not just NASA, but all of us, right? Our missions, incredibly complex and really bold. Like the appetite of the public, it's like, oh, you went to the moon already, right? Like, what do you got after breakfast, right? There's just this pressure to keep going, keep pushing even further, and that drives complexity. There is a huge industry base that wasn't there in the Apollo era, right? There's tremendous innovation happening all across our aerospace ecosystem. And so we want to take advantage of those partners, right? To be able to push and deliver all of those bold expectations. Speed. People have an attention span these days that is not to be trifled with, right? And we need to push on that, right? They'll lose their appetite. There's all of the constraints, of course, associated with administration, 4-year chunks, and many of our missions really have to transcend that. So the demand signal for speed is huge. Affordability, true for everyone. And then let's talk about transparency. Everybody wants to know every little thing about what's happening in our NASA mission development, and they want to be a part of it. From the students, who want to be able to do a CubeSat or whatever, right, to just the general public. And they always have an opinion, right? So these are really the constraints that we're facing in the world. What that means is we cannot be your daddy's NASA, right? We can't do things the way we have always done things and expect that we're going to be able to thrive in a world that looks very, very different. So, digital transformation. One of the things that we realize is that digital technologies writ large, right, have the power to change not only what we are doing, but how we are doing it. And maybe the what we are doing is maybe even less intuitive. I think a lot of folks, especially we were talking about the tone at the top. Senior leaders, I think, often understand that digital technologies can change the way that we work, but that it actually changes the product and the expectations is less intuitive, right? And so that's this kind of little kitschy thing about navigation. Just think about that, the function of navigation. What it looked like in a traditional sense with paper maps, and then we digitized it. I often find senior leaders have no problem understanding the concept of digitization, but transforming it is something else entirely, right? This is a whole new thing. This is now talking about point-to-point and being able to, incorporate the speed traps. And, there's actually a great interface that I'm starting to play with now, especially when I'm walking, that kind of does augmented reality and kind of helps you, see through and see your landmarks as you're navigating on the street. So when you think about your personal life, right, you see digital transformation in action all over the place. And what we are saying is this is a huge lever that we really need to strategically harness at NASA to rise up and meet that transform and changing world. So how do you kind of put a picture of what this maps to apps thing looks like in the workplace for NASA? So what we did is kind of recognize that the thing that brings us together at NASA always is our mission. It's our work, right? So if we were to go back to that mission and really look at what would doing that mission look like for individuals, personas, if you will, in the NASA environment, and really kind of unpack that a little bit. Let's put a picture on it. So what we did was kind of a persona-based exercise. We imagined a scientist named Sandra. And in the future, we're imagining that she's working on her, whatever scientific inquiry, and she's got a digital assistant out there to help her, flag various data sets and partner research that might be relevant to her area of work. So we imagine that her digital assistant alerts her to some newly published information. She's able to actually access that information, clean it, and ingest it into some models of her own, and be able to quickly assess that, hey, what they're finding might actually impact my research, and there may be a potential here for a breakthrough. Her next persona was Karen. Karen, we were imagining, is a financial analyst, so non-technical person. And what we were imagining here is that, she is just returning from what we call a collaboration jam session or a hackathon type event. And she has gotten to gather, just for a one-day event, with people from all across NASA who had the opportunity to just quickly get a shot in the arm on how to learn and really apply AI and machine learning tools for a spacesuit challenge, something that in her world she would never have gotten the opportunity to work on. By doing that quick hands-on learning and really getting exposed to some of the other folks that are from different technical fields, she has a whole new lens on how to approach some of the problems in her world, and she kind of gets that nice quick mission shot in the arm that can sometimes be elusive, right, depending on your function. And so she's just dying to come back to the office and share what she's learned with her peers. Our next persona was George. George is working in the fab shop, and he's got a digital manufacturing urgent job that's going on. And we imagine that he has some sensor that go off that says, hey, something is trending badly here on your production. And so he's able to actually suck that in, start to look at the trending and the data history in looking at the digital twin model he has of that part, and realizes that actually the anomaly that they're producing is going to be okay for the intended use of the part, and he's able to continue on with that job so that he's meeting the milestones. So these were our personas, and what they really represent is our top line goals. That fundamentally at the end of the day, the reason that we're transforming NASA and what we really need to accomplish is we need to transform the way that we're working. We need to transform the experience of our workforce, the engagement, and we need to transform the agility of our workplace. And we can unpack what those mean all day long. But suffice it to say, they're very broad, right? Digital transformation encompasses everything that we do. It's not focused in one single functional area. It's really about NASA writ large, extending to our partner community. So you have that kind of breadth. The next question that we need to tackle is, where will we start? You can't do it all, right? This is a little bit of a work in progress, and so you guys are getting a sneak peek, and since I kind of can tell from your program that you already get it, I'll be really interested to get your feedback. But the focus areas start with, because of course I am an engineer, and oops, gotta get to the there we go. So in my opinion, the world starts with engineering. So where we want to start our transformation is really, at the end of the day, NASA is about producing these missions, right? And so developing those missions is engineering, and we need to transform the way that we do engineering. It really needs to become all about enabling agile, so much faster, much more responsive, multi-center, multi-partner teams, engineering teams, to really work on some of these frontier problems. This is poking at the mission complexity. And we have attributes under the hood of what that looks like. And you'll see there are 4 coming here. But just as an example, we talk about what might a transformed engineering capability look like. We're talking about going from every system we might develop for like a ground experiment all the way through our operational flight missions, looking at multi-fidelity digital twins to enable, rapid concept to development to flight to operations, life cycle engineering solutions, integrating with partner efforts. We're talking about, again, our teams being sort of systemically multi-center, multi-NASA center is what we mean by that, multi-partner teams. We're talking about using a shared interoperable development environment that enables us to integrate our data and especially combine modeling and simulation and test artifacts and really use that to drive rapid exploration of concepts and design alternatives. Finally, it's about integrated cross-organization configuration managed data-centric processes. So this is about having some of those authoritative sources of truth for that broad, diverse team and really driving to some of the interdisciplinary approaches that we know are going to be transformative, and that includes things like uncertainty quantification. So each one of these has kind of a descriptor under the hood. But transform engineering, if we can do that, we'll be producing our missions in whole new ways, and those missions invariably produce data. That data is the source of discovery. Now, one thing that we know is true more and more over time is that NASA is not the only place, right, producing missions and producing data. And if we really want to get to the breakthroughs out there, it's going to be about combining those NASA experiment data with data from other sources. There is a huge amount of investment in the science, in the foundational research, in the early stage technology domain that is happening outside of NASA, well outside of NASA. And we want to be able to leverage all of that talent and that thinking for NASA's missions. So what does transform discovery look like? It's about multiplying those science and technology breakthroughs by leveraging all of that talent and advancements that's happening outside the NASA ecosystem. Once we have some breakthroughs, we need to make some decisions about what to do next. So our next target is about transforming the way we do decision making. I appreciate it, and I may steal a couple of words from General Masialo's talk about data informed. Here what we're talking about is really having risk-informed, self-consistent decision making. We often make decisions, whether it's at the program, project, or even up through like executive council level decisions, that are in their own little silo. They don't necessarily take into account what are some of the factors or previous decisions that have been made so that we're self-consistent over time in the way we're thinking about targets. So this one is all about transforming how we do that decision making and really making it data informed and quantifying risk. So this is where uncertainty comes into play. Finally, once we make a decision about what we're going to do next, we need to make sure that we have an environment to actually execute that mission. And I'll just say, the arrows kind of imply what I've been talking about, that these things are very much connected. But the operations piece is about really optimizing and synchronizing our work environment. And you can see nice government management words about efficiencies and effectiveness. But the kicker here is that we at NASA have a mission support side of the house, and that provides sort of some like base services. But that's not enough, right, to kind of birth work, to be ready, doors open to do work. There's a lot of other technical capabilities like calibration of the lab, equipment, data acquisition systems that are technical in nature that sit on our mission side of the house. And right now, the ugly truth at NASA is there is some fracture with getting that all to work well. I think probably any large organization has its share of fracture, trying to get all the organizations synchronized. And this is a target, right? This is what we mean by transform operations. All right, so this is a senior leadership conversation where we choose to really drive our efforts forward on transformation, that large effort. That has to come from the top. I so appreciated the words, the tone at the top. If we can get those targets set up, it actually gives our innovators, something to align toward, and that's hugely important. As we were talking in the previous, keynote, it isn't the leaders that know the how, right? They know the what, but there's a lot of innovation coming through the organizations, through the folks like this community that we really need to tap to kind of drive some of these advances forward. The problem is, at least at NASA, is that we're a very federated organization, and so we're kind of all doing it in our own little work unit compartment, right? And so we're having a very hard time multiplying all of that experimentation into scalable progress, right? So now what we want to do is really start to come up with a consistent methodology to mature that experimentation into scalable, practical solutions that can really drive those 4 transformation targets. So we call these, this is kind of our digital methodology. These are the digital levers. And kind of what we're saying is, senior leaders, you pick the transformation targets. Whatever you pick, great. But this is how we think you can systematically employ digital approaches to kind of help you architect that change you're looking for. First step is about establishing enabling architectures. If you read the fine print, hopefully you can read the fine print, this doesn't literally mean system wiring diagrams. This begins with an understanding of what is that function that you need to do in the case of engineering. What does engineering look like? What are the functions? What engineering is actually going to get done by the civil servants at NASA, for example? Because that's the work that we need to be optimizing around. Then you can start to have conversations about what's the underpinning technology layer that you need to support that. So when we talk architecture in this context, we mean business architecture, if those words mean something to the community. So that's the first step. Get your architecture down. Then, as I've just alluded to, you can talk about the processes that you're going to exercise to get that work done. Here, we want to talk about eliminating things that we've always done that maybe don't serve the new way we want to work. We want to talk about optimizing the work that does need to get done and bringing in automation where we can to kind of eliminate some of the manual steps. We also want to shift from kind of a paper-centric mentality, which is kind of a legacy way of working, to more of this data-centric mentality, which is fundamentally different, right? And we're also talking about bringing in, and you can see a nod to future of work embedded in here. We were having some great discussions in the hallway before we got started. But geographically agnostic. We at NASA, I think we had more than 80% of our workforce working from home for the last 2 years. And it's been some of the busiest mission seasons we have ever had, the number of launches, things we have done. So clearly we can get work done in a different way. It's not always ideal. There are limitations, right? I'm a big believer in breaking bread and kind of getting the relationships to where you can actually have some of the real talk in a quicker way. And that's a little bit harder to create sometimes. But we can take advantage of these things. And so we want to actually start breaking down the barriers. And by geographically agnostic, we right now have too many systems that are tied to like org code, which means geography. It's a NASA center base camped in Houston or whatever it is, right? And so it actually prevents us from tapping talent across the agency. So we want our processes to become geographically agnostic and team agnostic. Next, processes both ingest and produce data. Right now, our data is a little bit of a hot mess. You didn't hear it from me. So we need to kind of get our data house in order. Right? We need to really understand what are the critical data that we have, how are we stewarding it, who is responsible for stewarding it, eliminate the latent copies, synchronize the authoritative sources of truth, and really start to drive out some of the things that was talked about in the last talk. How do we bring in the capabilities for data fusion, data analytics, AI machine learning, so that we can really start to penetrate that data that we have. We have so much data. We are sitting on a gold mine. If data is the new coin of the realm, we are rich. But we can't tap it. We don't know where it is. So that's the next step. Then you need your tools, right? Tools operate and, again, produce the data. And so here we have a fairly big challenge with tool sprawl. Again, it inhibits groups from working together, right? When you use different tools and they really don't have the way to be interoperable. So this is about tool rationalization and really being business-driven, functionally driven, in thinking about where does it make sense to do things the same way across the whole entire enterprise? Where does it make sense to have a consistent way of working at the sort of functional community level? And where are you doing something that's sort of legitimately unique? And you really need to have kind of your own local way of doing things and being a little bit more systematic about that. Finally, and this is a last but not least story, it's about the teaming. This is kind of where we bring in the workforce and culture piece of this. You can see we have kind of a cheesy, inclusive, cubed teaming, and that's because we're thinking about inclusion on a number of different dimensions. In our workforce, we have multiple generations, right? Everyone from digital natives to digital dinosaurs to digital migrants, right? And we kind of, the what's the right way to say this? In the modern era, there's sort of a base capability that people are going to have, and we're going to have to honor that we have some great new talent coming into the workforce that actually can be our Sherpas, right? They may not know everything about, all the experience associated with, say, engineering of systems, but they bring other rich talents, and so we really need to be able to tap that to bring the whole community along. Geographically inclusive, we've already talked about. Organizationally inclusive really gets to the partnering aspects of things. So, the last little note on here is that hopefully you're appreciating that what we're talking about is a methodology. This is not come in and hit any one of these prongs. You really have to do kind of a coordinated attack, and that's because it's the people that use the tools that produce the data that are exercising those processes that kind of fit within that architecture, and all of that is what's required to drive your transformation. So think of these digital levers as kind of our digital methodology. You want to get to the cool tech under the hood. We call these our digital foundations. This is really like, okay, what are the digital advances that you really want to leverage here? And I'll go through these relatively quickly. So let me see how I'm doing on time. We're okay. Okay. Data and data science, we just talked at length about that. That's one of the core technology areas. We included this here. It's not really a tech, but this is really about that digital mindset and skill set. It's our culture and workforce. You cannot dismiss this in a digital transformation effort. In fact, it may be one of the most important things. Collaboration. Think of this as Zoom Plus, right? It's all the different ways that we enable our people to work effectively together and with the data. So it kind of extends, from, we're a team shop, all the ways we're leveraging platforms like that, but getting into like augmented reality, mixed reality, to be able to immersively engage with each other. AI and machine learning. My buddy Ed over there leads this for the agency. Model-based approaches, digital models writ large, any function. This is helping people to make sense of complexity. And process transformation. And so this is really where we're getting into things like optimization and automation of processes. What I want to also say here is that we are base camped. Our digital transformation effort in our Office of Chief Information Officer. And the reason for that is that our OCIO really needs to be providing some of these key foundations that you see on the screen. They have a plank-owning role in making these capabilities accessible across the workforce. And so we've had an amazing opportunity, particularly over the last about 6 months, to really lean in with them on our IT strategy at NASA to kind of start driving some of these capabilities to make them more accessible. So what I want to do now is flip over and say, okay, kind of laid out the strategy for you. Hopefully, as innovators, this gives you a little bit of a target to understand, to think about your work and how you might aim at it. But who's already leaning in? So we'll go through, if we have time here. Looks like we will. I got, I think, 5 examples. So what does this look like for some individual technical communities? So I'll start with our scientists. Here, what you're looking at is it's kind of a it's a different take on this. This is not getting deep into mining of particular climate data sets. This is about mining a body of knowledge, right? So we have an initiative at NASA. It's called TOPS. It's a Transform to Open Science. It's really all about how do we open our data sets and harness external data sets from maybe some disadvantaged communities who we haven't been tapping, but also, just the global science community in a more systematic way. And it's really all about how do we promote interdisciplinary discovery. We have scientists that are deep, deep, deep in their own world, but we've got Earth geologists that don't interact with Martian geologists, right? And there are things that we're learning across those communities that could really propel the research. So one of the things that we have done is we have birthed what we call an enterprise data portal. And what you're looking at on the screen is just some screen grabs of a pilot activity that we've done that has sucked in Earth science data into this enterprise data portal. So think of this as a front door to some curated data sets. And you can see if you kind of look down, try to get my cursor up here. You look down the side here. There it is. that we're talking about all kinds of different data. When this particular demo that I'm kind of screen grabbed from was a scientist who was saying, hey, I've heard of this mission called JEDI, and I think it might be relevant to my research, but how could I, what is that all about? So they come into the portal, they search for JEDI, they get a description of the mission, they get a full listing of publications related to it, so these are the refereed publications. Then they can kind of go in, and there's a whole taxonomy associated with the science community that's embedded in the portal, and they can start to see how the JEDI mission, if you can kind of see here, crosswalks to some of those key conversations and terms that we would want to have inside the science community and other missions that are out there, and how those may actually crosswalk. So this breadcrumb, you were interested in JEDI, it's kind of like the Amazon other buyers also were interested in, right? Like this is that breadcrumb trail, kind of searching through that. And then they can also go straight to those science data sets. So this is kind of that portal into specific mission measurements and how they were calibrated and all of that. And so the upshot of the demo that we've done is, this particular witness testimony, if you will, is from the scientist who said, hey, just by using this, and it is an intelligent search interface, so it does use natural language processing. It's not like a keyword match or anything like that. But I was able to kind of much more quickly learn about this mission and understand how it might be applicable to my research. And so this is really all about cutting down that learning cycle time so we can propel those advances and get exposure to work outside your silo. Next one we'll talk about. Let's talk about systems engineers. So we've got another pilot effort going on that is a digital twin of Orion. So this is really all about how we might manage increasing system complexity on systems like Orion, right? And if you think about Orion, it's a multi-partnered effort, and it's a campaign that goes over time, right? The Artemis is a campaign. It's not a single launch. So we're going to be taking this design, adapting it, maturing it, and what we want to be able to do is have a curated place where the design information, the test information, the mission information comes together so that we can make better forecasts and better decisions about how we want to use that hardware and some of the mission operations. So what we did is, from a model-based systems engineering perspective first, we sort of launched this digital twin, and we started with the electrical and power system. And where they are right now, you can see some of the stats that are in the lower corner here on the screen, but we've got a bunch of the components from that system in and the interfaces. They are incorporating test information, and they have gotten some of the ports ready to bring in command data handling, GNC, some avionics, I think, some of the other systems. So they're ready to kind of go. And we've got the Artemis 1 flight coming up, hopefully this summer, wet dress notwithstanding. And that will be kind of a big deal for us, right, is getting to bring in some of that flight data and see how this digital twin really helps that community to really much more quickly triage some of the anomalies that always happen on flight and be able to make some better decisions about what to do. Next one, let's talk about discipline engineers, which envelope folks in the test and analysis community, obviously. So this one is really born of some of the challenges that we are having on some of our most complex missions, where it's really sort of multi-physics phenomena that are coming into play concurrently, and we don't always have a way to test those combined physics on Earth, right? So what you see on the screen here, this video, is an example of one of those missions, and it's a Martian mission. It's looking at Martian landing. So, essentially the challenge there for where we're going with human-scale Mars missions is we have to be able to land a 2-story high spacecraft, comes in at about 10 metric tons with, of course, virtually no atmosphere to slow down, coming in at like 12,000 miles an hour. And how do you slow that down? What are your options? So there's a whole bunch of trades that we need to be able to do, right? One of the technologies is supersonic retropropulsion. That's what you're seeing a simulation of on the screen. Basically, let's fire some jets in the direction we want to slow down and see what that looks like. And so you have to be able to simulate the propulsion, the aerodynamics, the burn on the heat shield, the controls, all of that concurrently. Right now, our engineering methods are time-consuming. We don't always have quantified confidence in those predictions because it's hard to anchor them, right, those predictions. And so one of the things that we're trying to do is take advantage of next-generation compute platforms. So The simulation that you're seeing is actually a couple of years old at this point, but it was a partnership with our friends at Oak Ridge where we got to run on Summit some of these capabilities. And we had kind of a back of the envelope estimate on if we had even tried, if we had even tried, what would it have taken on NASA, current state-of-the-art compute capabilities to run some of these simulations? It was about 9 months or so, and these were done in just 4 days' time. So that's not saying we're ready to just flip over and poof, this is ready for practical use. This is a research campaign, right? But the point is, we really need to be pushing on making that leap to bringing some of these capabilities into practical engineering use, because this can really shorten the learning cycle and really help us start to close some of these complicated designs. So a couple things that we're doing here. First thing is this year, we've launched an initial phase of developing what we're calling a NASA digital engineering environment. It is really essentially an interoperable PLM framework, a product lifecycle management framework that can help us bring some of these discipline capabilities together, integrate the test and the analysis data, kind of get to that authoritative source of truth, and bring in, ideally at the end of the day, kind of leading to our second thing, confidence measures and uncertainty quantification. I know, where's Jim? A couple of the folks in the audience working on this. One of the things that we're doing in order to be able to do that is our friends at the national labs have really leaned in, of course, on the modeling and simulation. And so from a federal perspective, we're trying to start to architect some more robust partnerships so that we can co-create some of the solutions that are going to be needed in this space together. Next, let's briefly talk about project managers. So our project managers are also leaning in. This is where I'm thinking, oh, maybe I'll steal Wendy's words, because we have data-driven reviews. It is really data-informed reviews. Right now, kind of the way a lot of our project management reviews, we have, folks on the project have to stand down a day or two, whatever, create 2D charts for the periodic briefing, and they're trying to forecast what the conversation is going to look like. And invariably, there's a few misses, there's questions that get asked, so you get actions, right? And then that takes a couple of days to close them. So what we really want to drive to is having a better way we curate all of that program project management data so that we can kind of get to sort of instantaneous health understandings, really understand some of the trending. And ultimately, we want to tie that in to, take advantage of digital assistance using Ed's world to be able to tease out, hey, where are some of these trends flagging something that was a bad day on a past project? And maybe project manager, you should look into kind of what they encounter, because that could be a signal, right? A weak signal. We want to be able to detect those earlier so we can head off risk. Final one I'll flag to you is mission operations. So here, actually it was just, I think in December of 2021, we had what we think is a AI machine learning first in space, in the sense that we actually piloted an AI machine learning model on space station to do some, it was essentially image processing, right? Right now when we have gloves, astronaut gloves on space station, they have a couple of sets, and they do some imagery and inspection of those gloves to verify that they're actually ready for the next excursion, the next CVA. And that takes a minute, as you might imagine. You have a crew, this is high risk, that goes through all of that information. What we did was prototyped a way to kind of have the AI take that first pass and triage out a recommendation on, hey, is this a go or no go for next flight? And what we found is that that model predicted in about 45 seconds what had been taking a multi-person team multiple days to kind of get through. Now, that's not saying in any way that we're ready to flip the switch and let the AI do it. This is to really augment and kind of guide some of the human decision making and speed up what we're talking about. So we kind of took that deep dive into what we're doing, within the test and analysis community. And now what I want to do is kind of walk you backwards through this slide. Hopefully you saw from those examples how digital transformation is really driving some of these outcomes that we have on the screen. Better integration with partners through things like that digital twin, closing designs on more complex missions through some of that interdisciplinary analysis, faster decision-making and operations, inspiring citizens. I didn't mention it, but that AI glove inspection model got written up in Forbes. Microsoft just produced a super slick video. They were our partner on that work. And it's getting a lot of play, right? People eat that stuff up. Actually, I don't remember, Ed, did you go to Space Symposium this year? We actually featured this work at Space Symposium, and it was like packed. The crowds were packed looking at, of course, they want to see the actual glove, but they were enraptured by the AI part of it as well. And I didn't talk about this, but similarly, it's really about engaging our own workforce, right? There were questions earlier about, hey, what are you finding with the students coming in? Well, one of the things we're finding is they, in some cases, have more advances in their university environment than we do at NASA, and they come to the shiny meatball, and they're thinking about, all the wonderful things we do, our big, bold mission, and then they show up and they're kind of confronted with some of these paper-centric processes and, battleship-grade desks, and, it's just a little bit less than inspiring. So really modernizing the way that we work, it's about engaging our own talent, right, as well, and creating an experience for them that really will let them maximize the contribution that they can make and not have to spend so much time on some of the other stuff, right, that is required. So in order to do that, we're pulling on those foundational technology areas, AI among them, Ed's area, and really using these digital levers as a methodology to sort of systematically drive in how we're going to take advantage of those technologies in order to transform 4 target areas. And at the end of the day, that is really all about trying to fundamentally transform NASA. Because delivering that enduring, bold mission in a globally competitive, hyper-connected, technology-enabled world is going to require us to transform the way that we work, the experience of our workforce, and the agility of our workplace. So that is our story. That's why NASA is harnessing digital transformation. And hopefully, you guys can see that you are on the crusading front lines of doing this. As I mentioned, I trolled through the papers that you guys are presenting here this week. You're really pushing on the methodology behind that underpins a lot of this. It's really all about how do we take some of that work and drive it to scale? How do we bring it to practical use so that we can actually see these macro level benefits that we want, as opposed to just micro experiments, and that's really, at the end of the day, the trick. That's why we have an enterprise level digital transformation strategy. It's not that people weren't thinking about this. We're a technology hugging organization. People were leaning into this all over. It's about how do we drive it at scale and with our partner community. So I am excited that you guys are gathering, because having a forum like this where you can share and learn together, that's a key ingredient to kind of getting to scale, right? It's about how do we learn from each other and propel and start to create a consistent vocabulary for what we're trying to do. And that's how we'll actually start to get a force multiplier in the space. So thank you very much. I don't know if I have time for questions or not. No, I'm actually over. Sorry. Ed will tell you I do that all the time. But I am very excited for your workshop, and I really look forward to hearing what you guys come up with that drive digital transformation. So thank you.